So welcome to Thomas and Rhonda and Ian so far.
Hi guys, welcome.
Yeah, we still only have 3 people, so we have approximately 12 to 13 that are coming along this morning. When we had to change the time, we had about 20 odd, but some people couldn't make it on the Sunday morning. Our apologies for that. But we'll have these, depending on how this goes, we'll have these on a more regular basis. Yeah, anybody that's missed out so far will be able to attend the next few that we have, and of course you're welcome as well.
Well, we may as well start, Dave. So if everyone else comes in a bit late, that's fine.
Yep. Okay. Well, welcome everybody to a bit of a glitched webinar at this stage, but I'm sure they'll get better as time goes on. The people that are here may have or may not have met Christopher or spoken to him in the past. My name's David Ellery. I'm Christopher's brother, and I'm located in Adelaide, and I tend to handle the business and online end, I suppose, of SFI. A little bit of history. My background is over 25, nearly 30 years in the waste management industry, and most of that being in recycling and treatment of organic wastes. So that's where the link with SFI began for us many, many years ago, back well before year 2000, when Christopher and I were involved in that. Prior to that, as most people would know, Chris had a fairly extensive background in horticulture anyway. So that's a little bit of an introduction. For people that can't see this, you will be able to see this on our YouTube channel. So if anybody types a question, then I'll repeat it, and Christopher or myself will answer it. So hopefully everybody can see this, the people that are here with us. We have one person that's asked a question here. Looks like Thomas. If you can hear us, Thomas. I'm going to hand the. I'm going to bring Thomas up, Christopher. So we'll see how we go.
Okay. Sure. Welcome, guys. No one rings a bell, but that's fine. Yeah, so while Thomas is getting ready to ask his question, which he's quite welcome to do verbally or by writing in the text area. Yeah, as David explained, SFI Australia have been sort of working in Australia now for about 15 years. Basically, SFI was started by Dr. Ingham, as you guys would all probably know if you know anything about soil food web. Dr. Ingham's based in Oregon or California in the United States, and has been vigorously pursuing the aspects of soil microbiology for 30-40 years. And is probably one of the pioneers in the world. And as David explained, we started working with SFI, excuse me, about 99, I think it was, where we met Dr. Ingham in the States when we were over there doing a big conference for vermiculture, actually, worms. So we were processing a lot of worms and thermophilic composting, and that's how our relationship started. So basically since then we've been all the way around the world and worked with a lot of different people, and we are responsible for Soil Food Web Australia, and we work very closely with Dr. Ingham. We're hoping to get Dr. Ingham out here in August this year. It's been about 6 years since he's been to Australia due to sick. So We thought we would start the ball with our webinars, and as you can probably see, this is our first one, so please bear with us, and hopefully we can answer any questions that you have and try and work with you guys to get some good, healthy, sustainable soils or compost, etc. Okay, how are you doing there, Thomas? Now, if you have a question, which I'm sure you do, hence the reason why you're here, you're quite welcome to type it in if that makes it much easier for you. You'll see over to the right, you should see a little area that says write your message here, where you can type a message in or a question, and I will verbally answer it. If you can't hear me, I will type it out for you. Okay, can you still hear us, David?
Yep. Can you hear me? Hello, can you hear me?
Yes, I can hear you. Can you hear us?
Yep, I can hear you, no problem.
Okay.
Okay. Oh, Ian's here, so Ian can I think, not sure, can you hear us, Ian? Not sure whether you can hear us or... Okay, so you see the question that Ian's asked. Christopher, I'll let you answer that.
All right, Ian, to make your own inoculant, first of all, obviously you have to start with the particular mycorrhizal that you wish to use. And there are thousands of different types of mycorrhizal fungi. So what I would suggest you do is to investigate what would be the particular types of species you would be using. And that's pretty easy. There's actually a website that you can go to. It's called the Mycorrhizal Association. And just type, or you can just look through there and you'll see there's a vast amount in regards to the type of mycorrhizal that particular crops prefer, from our understanding. And then it's just a matter of there's a number of different techniques, and you can actually find them if you just Google them, rather than going through it here. If you just go onto Google and type in how do I breed mycorrhizae, you'll find there's a heap of information on it. There's a number of ways you can do it. Basically, mycorrhizae have to have an association with the root, so you can either grow your plants in containers and inoculate the seed or the roots, and then you can harvest that inoculation, the spores that come from that. But the important part is that you can actually you can verify them under a microscope. You probably need to have a little bit of microscope training if you haven't already had it, and so that way you can work out whether they are mycorrhizal spores or whether they're some other type of fungal spore.
I don't know, has that answered the question, Ian? Oh, yep. So you've heard all of that, Ian. That's good. You have another question? By all means, ask. Anybody else? I think Rhonda's still there. So if Rhonda has a question, but Ian, if you have a question, mate, you've got the floor to yourself.
Any more questions, Ian? Yeah, you can buy them. There's a number of reputable people in Australia, and I would definitely buy them from Australian suppliers. You can buy them from the States, you can buy them from all over, but you'll find there's a number of reputable dealers. And again, you can quite easily source that on Google. There's a company called New Edge Mycorrhizal, I think the name of the company is. There's also another company in Western Australia. There's a company in South Australia. There's probably a half a dozen of them in Australia where you can buy specific types of mycorrhizal. Nutritech Solutions is another one. So yeah, there's plenty of places out there, Ian, that you can source it from. It may take you a little bit of time to understand the association between mycorrhizae to get that right, but that's part of the enjoyment, part of the thrill, those sorts of things to improve your techniques.
Okay, so hope that was helpful, Ian. As some of you or all of you are probably aware, SFI or Chris runs a number of hands-on face-to-face courses at our site in New South Wales. Composting, compost tea, basic microscope course, and the second one following straight after that is it the intensive microscope course, Christopher?
No, that's the intermediate microscope course. Basically, the first course is all about how to make high quality compost, soil biology in general, how that interacts, what's the point of making it, how to make specific types of compost for different purposes, particular types of crops, for example, or making it for compost tea or liquid extracts. The second day is about how to make those extracts and teas, because the problem you have with compost is that it can be rather difficult to put out on a large area if you don't have the machinery. So we developed a process called compost tea and compost extracts, where we can basically create a living liquid that does a similar role to compost, and that's much easier to apply. And the third day is really just about basic microscope work and teaching you how to qualify the quality of the liquids that you've made from that compost or other types of potentially packet type inputs to make it tea extract from. And then the microscope course is a 3-day fairly intensive course where we teach you basically how to look at your compost, how to look at your soil, how to look at situations where you've applied a particular product or you may have made, or a good example is trying if he's propagating his own mycorrhizae, we can basically show him how to get a general idea of whether or not he's getting populations in his soil.
Looks like Ian has a couple of more questions there for you, Christopher, so away you go.
Sure. My thoughts on anaerobically fermenting plants and then using this anaerobically smelly brew to add to actively aerobic compost teas. Well, I've done that, Ian, and I haven't seen any detrimental results. The issue is what you usually get from an anaerobic fermented product is facultative anaerobes, which are things like, for example, lactobacillus. And those guys prefer, or they'll live in an aerobic environment and a non-aerobic environment. And if anyone doesn't know what aerobic means, it just simply means oxygenated. And anaerobic obviously means non-oxygenated. So yeah, I've used them, mate, and you can, I mean, a good example of that is bokashi. The bokashi compost, for example, is a facultative process. But when you put it in the system, what will generally happen is some of those aerobes will probably be outcompeted. Some of those facultative anaerobes will be outcompeted. So you will get some benefit from it, but you also will probably get other benefits like plant growth hormones, enzymes and things like that come from the byproducts of those organisms. I hope that helps.
All right. So at this point, we haven't heard from Rhonda or Thomas. So I'm hoping they're there, or perhaps they've dropped off the system. No worries, Ian. No problem. So, by the looks of it, sorry, mate. Go ahead.
I was going to ask Ian, what's he trying to do in regards to doing the mixes? What's his thinking? Is he trying to look at a diversity, or is he trying to look at whether or not those organisms will survive in an aerobic system? Just depends, really. You'll find, for example, when you're going into a compaction issue, for example, those. Okay, fine, all right, no worries. When you use those sorts of inputs, you know, the thing that actually helps, what you're probably talking about there, and is what generally happens is weeds are obviously indicators. And a lot of times weeds, depending, I mean, this is a very generalized answer, but a lot of times weeds are happening because you have a compaction problem, or you have an excess in certain types of nitrogen or phosphorus and things like that. And so when you will bring in a product like that, then the facultative anaerobes are the first ones that help break those high rates down. They help to create a more aerobic environment within a compaction zone. Okay, so they're the first ones that generally start to work in those systems, and then as the material, as the soil starts to become a little bit more aerobic, then your more aerobic organisms will start to play more of a role. Okay, well, that's great. One of those would be hemp, for example. Hemp is a very good soluble aspect, but plants in general, from my understanding, don't really solubilize. What they do is they provide certain types of byproducts which feed the biology, those specific types of biology that solubilize those minerals that become then available. That's right, they are the pioneers, because those aerobic organisms cannot handle the lack of oxygen, and they generally cannot handle the amount of gases and alcohols that are produced by the anaerobic organisms.
All right, so it looks like Ian is getting the floor today, this morning, so good one, Ian. I can't get a response from Rhonda or Thomas, Christopher, so they're obviously having trouble connecting.
That's a shame, but you know, as we've got to iron out the bugs, and I guess part of the problem with this system is if you haven't got a very good connection.
That's right.
Depends, Ian. David, Ian's asking, you can probably see it, but he's asking me what plants could be used for.
Yeah, I can see that.
Depends on what you're trying to do, mate. If you're trying to make a particular type of compost for specific purposes, then you would look at obviously the plants that you're going to use. If you're using plants as your base material, plant material, whether it's hay, straw, you know, weeds, particular cuttings off of different plants, etc., and stuff like that. Now you can get a general synopsis of what a lot of plants will bring minerally, for example, i.e., you know, for example, something like a acacia species will bring particular types of you know, more nitrogen, for example, than bamboo, but bamboo, for example, will bring more silica, more calcium. So from a mineral point of view, you can sort of look at a compost input to see generally what they're going to bring. But always remember, it depends on where those plants are grown. So if you have a really healthy soil and you've got heaps of minerals available to plants, obviously in those plants you're probably going to have higher mineral aspects. Whereas if you get them from an environment which is, really struggling, you would find that those same species of plants won't have the same amounts of minerals. From a biological standpoint, I don't think there's really that much information out there what specific plants bring specific biology. Again, if you're using a plant, then obviously I would try and also get the roots from the plant, if possible, from a compost point of view. But if not, that's fine. Because, for example, we know things like lucerne and hay and even wheat chaff and all those sorts of things generally will bring a lot of protozoa, for example, to your compost. Okay, but in saying all that, if you make your compost and you don't make it correctly, then a lot of those organisms won't survive. So it's really important that if you're going to spend the time to blend different plants for different purposes, you make the compost at the best ability you can, i.e. don't let it get too hot. Try and make it aerobically as much as possible. And one of the reasons we talk about the aerobic aspects of compost is because anaerobic conditions create gases. And those gases, a lot of the times, are basically the byproduct of those anaerobic organisms. And unfortunately, that byproduct tends to be things like ammonia, which is nitrogen. So sulfide ammonia is another one. So phosphorine gases and things like that, which basically you want to keep in your compost and your organic material as much as possible. Otherwise, they become gases and you lose a lot of your mineralization. And you also obviously lose a lot of the ability of particular types of bacteria and fungi. Yeah, I think it's important because you have to remember that your biology, just like us, uses minerals as well, not only your plants. So your biology will use minerals. They need minerals, just like us, to basically to play their roles and to reproduce. If you're looking at mineral aspects, then I would probably EAL, which is in Lismore, just up the road from you, mate. At the biological aspects, then obviously you would come to us, or hopefully you would. We're only up the road as well. There's a number of tests, but I would probably recommend you give EAL a call and explain to them what you're doing. But we normally would look at something like what's called an RA Pack 1, which gives you your general synapses. So it will give you, for example, all your MPKs, your minor trace elements. It gives you your nitrogen to calcium ratios, etc. If you're also wanting to look at making specific C to N ratio blends, then again EAL can help you with that, because you'll just send them, for example, say you have for example you have 3 main ingredients that's going to be the bulk of your compost. You can send each one of those ingredients, some of each one of those ingredients into EAL, and I think it's about $30 or $40, and they will give you the C to N ratio of that input. So for example, if you're wanting to make a highly fungal type of compost, then we know, for example, you need to make that at around 35 to 45 carbon to nitrogen ratio. In fact, even higher in some situations if you are, for example, growing trees, or you're growing fruit, and things like that, we know that you need to get that soil really highly fungal. So you would make a highly fungal compost for that purpose. I hope that helps. Yeah, sure. No, mates from Lismore, we're actually based in Wairala, which if you're from up this way, you would know where that is. It's 5 minutes out of Lismore. So we're not based at the university anymore, simply because we found that after 13 years or so, farmers just didn't, most farmers actually were quite scared to come to the university for some strange reason. So we decided that one of the best ways to progress was to set up on farm. And so now we've set up on a place that we're surrounded by about 280 acres, and it's a stud cattle farm. But we have our own section on there. You're welcome, mate. We're glad to have you. We're just sorry that we seem to have so much trouble with our first webinar, unfortunately.
Well, you may not be aware, but there is a production arm of SFI which is attached to, well, sort of attached to SFI, called ASBS, and that manufactures a lot of the inputs, etc., that are required to make these composts and compost teas. ASBS basically takes the science of SFI through the laboratory, etc., and then helps farmers to translate that into real hands-on product, and also equipment that may be needed. So keep that in mind, mate. We have a website. ASBS has a website for that, as well as Living Soils website, where you registered for this webinar. So yeah, if you want to know the address of that site, or perhaps you've already seen it, then by all means just ask.
Yeah, so Rhonda, and so I've just got Rhonda as the other person in the room. Is that right?
Yep, that's correct. Thomas was here, but he's gone. I think Thomas was actually from France. He had a bit of a problem, I think, probably logging in. You know, that happens with webinars, unfortunately. I've been an attendee of the webinars, 400 and 500 strong. Webinar software worldwide has not yet been perfected, but it's still a very good method of doing what we're doing. So the advantage of this, of course, is that it will all be on our YouTube channel, and people that have missed it will be able to see it. And everybody that's registered for the webinar will get a webinar replay link sent to them soon to know where that is. Yeah. All right. Well, we'll close it down, Ian. If you don't have any more questions, then I'll just turn my camera back on. If you don't have any more questions, then we'll shut it down for now, and we'll let everybody else know when one of these are available again. Obviously, Christopher cannot possibly, or we cannot possibly answer every question that you've got on a webinar. That's why we have the courses, the face-to-face courses. No worries. Thanks, Ian.
Yeah,
so we'll let off now, and thanks for thanks for asking the questions, but more to the point, helping us test this out. So great stuff. Yeah. Good.
And don't forget, Ian, to hang on, Dave. Don't forget, Ian, if you're still there, mate, to register for Dr. Ingham's webinar, which is coming up on the 18th, I think, of February. And has far more knowledge than I do. So please try and get to that one, mate. I think you'll find you'll get something from that as well. Good on you, mate. Thanks for coming.
Okay, bye, everybody.